Good day everyone, my name is Jean Marlwin El Gamboa. I'm the programmer in this group. I'm responsible for making the program and explaining the program in our Arduino.
Good day everyone, my name is Arshad Tajihid. I am one of the designers in our Arduino project.
Good day everyone, my name is Jerovic A. Ballesteros. I am the documentator of this group. I am responsible for checking and managing the Arduino hardware and software, checking the condition of each components.
Good day everyone, I'm Luis Enrico, A. Quintos, and I'm one of the Arduino designers. And together,
We are the group for BGQA TRONIX.
Arduino project number 15. This project is all about an Arduino IR controlled LED matrix project that uses an IR remote to wirelessly control what's displayed on an LED matrix. The Arduino receives signals from the remote via an IR receiver and then updates the LED matrix with different numbers, patterns, or characters based on those signals. So let's go ahead and start the Arduino project number 15.
Good day everyone, this will be the items that will be needed in building Arduino project number 15, Integrated Control LED Matrix. First, the prototyping sheet. This will be the main components in building Arduino project number 15, Integrated Control LED. Next, the jumper cable, male to male, used to make electrical connection between components to the breadboard, the Arduino board, and the internal modules, like the IR receiver or LED matrix. Male-to-male jumper wires are specifically used to connect male pins, like those on the Arduino or breakout boards, to other male headers or breadboard holes. Connects Arduino to breadboard and components. Next, resistor 220 ohms. Limits the current to prevent the damage to the LED in the matrix. LED requires a current limiting resistor to avoid burning out from too much current. The 220 ohms values is commonly used to balance brightness and safety. Protect LEDs by limiting current. Next, eight-segment LED. This is the visual output display in the project. It lights up in patterns to display symbols, animations, or message. In this project, the LED matrix responds to IR remote signals. So pressing buttons change that shows on the matrix. Display patterns or symbols controlled by IR remotes. Next, the IR receiver module detects the emitted signals sent by the remote control and sends the decoded signals to the Arduino for processing. Last but not least, mini IR remote controller. The input device, it sends inputted signals with specific codes when you press its button. The Arduino inputted these signals and controls the LED accordingly. Good day everyone. Today we are going to build the Arduino project number 15, the Integrated Control LED Matrix. First, insert the 8-segment LED in the center of the breadboard. Second, the 220 resistors inserted in a 8-pin segment. Next resistor, inserted in an 8-segment pin. The next resistor, inserted in F pin of 8-segment LED. The next resistor, inserted in a G pin of X 8-segment LED. And the fifth resistor, inserted in an 8-pin of X-segment LED. The sixth resistor, inserted in a D pin of 8-segment LED. The seventh resistor, inserted in a C pin of 8-segment LED. And the last resistor, inserted in a DP pin of 8-segment LED. And next, the IR receiver. Insert it to 453 pin. Next, the jumper cable one. Insert the first jumper cable to 11 pin to another leg of IR receiver. Next, the jumper cable, insert it and insert it in the negative leg of a IR receiver, the drum. Next, another jumper cable, insert it to the positive leg of a IR receiver and insert it to 5 volts. Next, another jumper cable wire. Insert it in a COM pin in 8 segment LED to 5 volts. Next, another jumper cable one. Insert it in COM pin of 8 segment LED to the 5 volts. Next, another jumper cable one. Insert it to ground pin in 5th pin. Next, another jumper cable. Insert it to the 13th pin in the 4th pin. Next, another jumper cable. Insert it to the 7th pin to 3 pin. Next, rather jumper cable 1, insert it the 6 pin to 2 pin. Next jumper cable 1, insert it to the ground pin to 6 pin. The next jumper cable, insert it to the 13 pin to 7 pin. The next jumper cable was insert it to the 8 pin to 7 pin. The next and last jumper cable wire, insert it to nine pin to 6 pin. That's it. This will be our Arduino design for project number 15, rated control LED matrix.
This is our code in Arduino project number 15. Remote controlled LED. Include irremote.h to include irremote library. Constant int receive pin equals to 11. This is the IR receiver pin. IR receive pin. This is the IR receiver object. Decode results. This is the IR result storage. Int current numbers equals to 0. The current number to display. Now for IR codes for buttons 0 to 9, decrement, increment. Long codes 12 equals. Now all of this code is you can get in your serial monitor in your Arduino IDE. For segment patterns for digits 0 to 9, for 7 segment LED, int number 108 is equals to. Now all of this code is to display the numbers from 0 to 9 in the 7 segment LED. For function to display a number on LED module, void number show int I or int pin is equals to 2, pin is less than or equals to 9, pin plus plus. Digital write, pin number I, pin minus 2. Void setup. Serial begin 9600. To start serial at 9600 baud so you can see debug messages on serial monitor. IR receive enable IRIN. Starts the IR receiver hardware listening thread in the library. For int pin equals to 2, pin less than equals to 9, pin plus plus. Pin mode, pin output. To set pin 2 to 9 as outputs for 7 segments. Digital write pin high. Initializes segments. Serial print line ready to receive IR signals. Prints a ready message. Void loop. If IR receive.decode and results, this is to check whether an IR message has been received and decoded. For int I equals to 0, I less than to equals 11, I plus plus. If results.value is equals to codes I and I less than equals to 9, this is to display number. So to display number from 0 to 9, number show I, current number equals to I, serial.print number, serial.print line I, then break. Else if results.value equals codes 10 and current number equal or greater than 0. This is now the numbers to decrement. Current number minus minus. Number show current number. Serial.print decremented to serial.println current number and break. Else if results.value equals codes 11 and current number less than 9. Now this is in increment. Current number plus plus. Number show current number. Serial.print incremented to serial.println current number. Break. Serial.print row IR code 0x serial.println results.value hex. Lastly, IR receive.resume. So all of this is to tell the IR library to resume listening for the next code.
You can save by clicking the 1 to 9 button in a mini controller. The IR receiver received the signals and it shows a 8-segment LED. This will be our final output for project number 15, Imperated Control LED Matrix.